Architecture is the mapping between form and function, and we're going to return to our example of the cable-stayed bridge to show this mapping. By looking at the figure, we can see the elements of form, the towers, the wires, the roadways, and so forth. And by looking at the functional architecture, we can see the internal processes and the associated internal and external operands, the redirecting of the vehicle, the supporting of the vehicle, the carrying of loads, and so forth. The next step is literally to map the elements of form onto the elements of function. And this is done with the instrumental relationship. Remember the round-headed arrow. So now we read this, that the barriers are the instrument of redirecting the vehicle, and the roadway is the instrument of supporting the vehicle and of carrying the compressive load in the roadway. So now we have it. We actually have the map of the architecture of the system, where we see the operands, the processes, and the instruments of form. We can ask questions, is the function enabled by these elements of form? Is it complete? Is it consistent? And we note that the relationships between the elements of form and the processes is the instrument relationship, while the relationship between the processes and the operands is the effect or consume or produce relationships. It's also possible to add on the structural information amongst the elements of form. So the barriers are in contact with the roadway touches the wires are connected to the tower, and so forth. And here we now have all of the information about the architecture in one diagram. We can flag up whether there are any missing interactions, and we can tell whether we have a complete set of elements of form necessary to be instruments for the processes. Note that the relationship amongst the elements of form is this open-headed structural relationship. Well, there's a very similar type of bridge to a cable-stay bridge, which to the naked eye, to the informal observer, you wouldn't really notice the difference, and I'll point it out to you. In the cable-stay bridge, the cables run at an angle, so that when they carry load, they put compression into the bridge roadway surface. In the suspension bridge, the wires run vertically, so they put no compression or tension into the roadway, but in fact, they load down this grouping catenary wire, which goes out into the shrubbery where you can't quite see it and is attached to an enormous anchor. So now we can put side by side the system architecture map of the two bridges, the suspension bridge on the left and the cable-stay bridge on the right, and see that they're really very similar, but there are a few subtle differences. The cable-stay bridge has this compression in the roadway where the suspension bridge doesn't, but the suspension bridge has this extra element, the anchor, which plays a role in carrying the tension in the wires. This is a really good example of how this type of analysis can make very obvious a rather subtle difference in the architecture of these two systems. We can also return to our pump and see how we can use information about the system architecture to better understand the function of the pump. Again, we'll start with the primary value flow functional architecture shown here on the left-hand side. We have the cover, which participates in inflowing, the external to the internal flow, the impeller, which accelerates the internal flow, and so forth. But there's still some pieces left from this reverse engineering view. We have a seal and a slinger and an O-ring. What do these pieces of form actually do? Well, the answer is they take care of non-idealities that occur in everyday life. You can't build perfect systems. There's always extra things you have to do. You have to store things or power them or energize them or move them around to keep them contained. And in fact, on the next image, we see the actual role of the seal is just to contain the fluid while it's being pressurized. The role of the O-ring is again to contain the fluid. The role of the slinger is actually to sling water which is leaked out from the pump away from the electrical motor. So we now have a relatively complete version of the system architecture of the primary value flow processes and operands, including the non-idealities, but we still have things like the motor and the motor shaft and the power supply. What do these elements of form do? In the next image, we can see locking nuts and motor shaft and screws and motor actually are the instruments of processes which support the instruments which support the value process. And even one more layer away, the power supply and the mounting are accompanying systems which support the motor, which in fact is then the armature around which all the rest of the system is built. So you can see there are sort of layers of the system here. There's the operands and the value processes and the instruments which support the value processes. And then there's ways of supporting them with another layer of instruments, and then eventually there's the accompanying systems. The last thing we can do in this diagram is flag up the interface as the water comes into the pump, inflows into the pump. And we see, interestingly, this interface has an aspect of a formal interface. There's elements of form to it, and the interface also has a functional aspect. So we'll introduce this little diagram of an interface, which not surprisingly has both form and function. It shares an operand and a process across the interface, and there's one piece of form on one side of the interface and one piece of form on the other side of the interface. So as this example, we have the internal low pressure flow, which is inflowing, facilitated by a pipe outside the system and by the cover inside the system. So in summary, we've learned a lot about the architecture of systems. We've developed a semantically exact notation to show functional architecture, the mapping of form and function, and the structure of form. We've found a way to identify interfaces to accompanying systems, and all of this is in one diagram. So we have a tool, a very useful tool, for developing architecture from form and function, communicating architectures, reasoning about emergence, creating and comparing architectures, and quantifying interfaces to our system.